And the last thing that we're going to talk about today is in section 16.5, which is on strong acids and strong bases. And we're not going to finish this section today. So we're only going to do the first half of it, and then we'll do the other half tomorrow. First thing that we need to do is define strong acids and strong bases. And we're going to start with strong acids. Now I want you to understand that saying strong acid, when we use the term strong acid, this has absolutely nothing to do with how corrosive or powerful or potent the acid might be. It has, even though it kind of sounds like strong acid should be one that, you know, would eat through anything, that's definitely not how we use the term in chemistry. In chemistry, a strong acid is defined as one that reacts completely with water. Reacts completely. For example, HBr, which is one of our strong acids, when you mix it with water, they undergo total reaction, complete reaction. The products are Br minus and H3O plus, and this reaction is not in equilibrium. And that's what it means to be a strong acid. When you put the substance in water, you get a forward arrow reaction, not an equilibrium reaction, 100% conversion of the acid and water to the products of the reaction. There are only 6 or maybe 7 strong acids, depending on who you ask. What book you might be looking at. All chemists agree HCl, HBr, and HI are strong acids. We also agree nitric acid, HNO3, and HClO4 are also strong acids, and sulfuric acid, H2SO4, is a strong acid. Although I want to put a note on here, sulfuric acid, H2SO4, is a diprotic acid, and remember I told you with a diprotic acid, the protons, the hydrogens come off one at a time. For H2SO4, the first H plus that comes off of this acid is the only one that is strong. So the first loss of H plus is a complete total reaction, but the second H plus that gets removed is not a strong acid and not a total reaction. And then, so that's 6, and all chemists agree that all 6 of these are strong. And then some resources say maybe HClO3 is also a strong acid. So definitely the first 6, and then possibly also that 7th one is a strong acid as well. And all the other acids, literally all the other acids, are defined as weak acids. And weak acids, again, has nothing to do with how much it will hurt if you spill that weak acid on yourself. Like HF, hydrofluoric acid, which is a weak acid, and this thing will literally eat right through your skin, straight to your bone, and eat through your bone. HNO2, nitrous acid, acetic acid, CH3COOH, carbonic, H2CO3, HSO4 minus, HCN, H3PO4. That's just a few. These are the ones that you're going to see the most often. But literally anything that is not one of the 6 or 7 strong acids, it's going to be weak. So we also